G'day everybody, Nick Dingle here again. Welcome to the third part of our text-based game video. Now I've just added a few little comments above our classes there. Nothing else has changed since the last video. But in this one we're going to tackle the biggest, the meanest and the hardest class of all, and that is the level class. And it's going to store information about where our player is, how many enemies we got, the items in our world, all the individual rooms and how big our world actually is. We're also going to add functions to move around that world, save and load different levels, display things to the screen, get items and get enemies by their reference. So heaps and heaps of stuff this is going to do. That's why I left it to its own video. So it stores the level information. Wow, can't type today. And allows world interaction. So this is why it's so frigging massive and so complex, unfortunately. And it's just going to be this video dedicated to this guy. Again, if you got stuck or you didn't manage to get everything 100% or there's errors or something like that, the source code for the end of the last video is down in the description. Please go grab it. Now, one thing I just want to make clear before I start writing up the level class, I didn't come up with all this stuff off the top of my head. I didn't just sit here and go, I'm going to need this and for the items, and this for the humanoids, this for the rooms, and this for the levels. I started with what I thought was going to be the bare minimum, and then I added to it, and I changed, and I moved things. Originally, I didn't have these item references or humanoid references. I had to add them at a later point when I realized that I wanted a global list of items, and I only want to reference them in the player's inventory or in the levels. Okay, so none of this stuff comes off the top of your head unless you've done it for years and years and years and you know exactly what you want to do. Sometimes you just got to try it and see what works best for you, and that's literally what I've done. So let's set up our level class. Sorry to yabber on. Let's get cracking in this bad boy. So first of all, we're going to have a property which is where the player is going to be. I'm going to call him player position, and I'm going to make him as a vector 2. A new vector 2, I should say. And that's going to be where he is positioned around the world. We're going to use this for the editor to move him around. We're going to use this in the game to move him around. And we're also going to use it as the starting position of the player when the level loads in the first place. Because you don't want the player to always start at the 0, 0 in the top left-hand corner. Sometimes you want him in the middle, down the bottom, things like that. Let's make a player as a humanoid. Well, not just a humanoid. We're then going to have a section for all of our rooms. Now, it's a 2D world, okay? So we can go across the x-axis or down the y-axis, and that's why we have a vector 2 here. So I need a two-dimensional array. I don't know how big it's going to be initially, so we'll leave it blank, but you put a comma in the middle. And what we just created there is a two-dimensional array of rooms, but we haven't specified the width and the height. So obviously we can't use it at the moment until after we declare how big that two-dimensional array is. So on that note, let's set up the width and the height as integers. All right, so this is all the information about, let me just put a space there. So this is the player information just here. This is the rooms information, or I should say the grid, or whatever you want to call it. And this is going to be our global lists information. So we're going to have a list of items just here as a new list of items. Believe it or not, that's what we're going to write it as. Okay, public enemies as a new list of humanoid. There you go. So that's all set up and ready to go. And really what we've been doing in the previous video is create a constructor. I'm actually going to leave that out of this equation. I am going to have a new, what have I done? New map function instead, where the user gets to pass me a width and a height. All right, and this is basically going to forego our constructor because I want to be able to call it after we make the level variable, that is. Okay, so let's set up the map. Let's create a brand new empty map. So me.width equals width, so we can back up the width and the height so we can remember it for the future. And then we're going to redeclare this array with a size from width and height. Okay, really bloody easy. You just type in redim. Okay, and then you type in your array name, width, height. Okay. Now, if they want 10 rooms across and 10 rooms down, then we're going to have to put a -1 here and here. Simply because if they type in 10 for the width, and we put 10 here in an array, you're declaring 11 rooms from 0 to 10. But if we put -1, it'll be 0 to 9, giving us 10 width and 10 height. And now here comes the arduous thing. Because we have this as a custom class, we've got to go through every single room and create a fresh one. So we have to loop through all the rooms, creating empty rooms. So 2 loops, for x equals 0 to width -1, for y equals 0 to height -1, and then you go rooms, xy equals new room. Alright, I know how crap that looks. Now, finally, let's create the player. So player equals new humanoid. Let's give them a name, which is player. Their max damage, let's say for the moment, is 10. We can change that later. Min damage is 1. Max health, 100. Alright, done. So for the moment, this is our how we create brand new levels. And what am I doing? I shouldn't call it new map. New level. That sounds much, much nicer. Okay, if you need time to pause that and write it all up, because I'm about to jump into a function for moving the player. Alright, so let's jump down here. Let's go public function move player, and I just realized that I didn't put a public in front of this, and it's good practice. Now, for move player, we're going to take 2 things. We're going to take the direction they want to move. So, direction as direction. And then we need to know, are we moving as a game player or are we moving as an editor player? Now, the difference between those is a game player will, if they hit a blocked wall, they're not going to be able to move. In an editor, we should be able to move no matter what, even if there is a blocked wall. So I'm going to have an optional parameter called editor as a boolean, which equals false. So what that means is if we set this guy to false, he's going to adhere to the laws of our blocked walls. If this is set to true, okay, then he won't adhere to those rules. Now the reason I made a function is because I want to return a boolean. And this boolean is going to tell us whether or not the player did move or did not move. Okay, first check if we are in the editor. Okay, so if the editor equals false, so this is we're in the game, so we have to adhere to the rules of our movement. Okay, our blocked walls. So we're going to go select case dir, and we're going to check which direction they moved in. So case, if the direction is north, they're trying to move up. Okay, so what are we going to do if they want to move up? Basically, you're going to go the player position dot y -1. So you're reducing their y coordinate by 1, moving them up. So that's moving north. However, we're not currently adhering to any rules of blocked walls. Here's the tricky part, because A, we can't go below 0, and B, we need to check if the north wall is blocked. So unfortunately, each one of these guys is going to have a big ass if statement around it. Okay? And I must apologize for that. So let's do this now. So if player position dot y is greater than 0, okay, that's going to stop us going into the negative values, and room sorry. Now, what room are we in? We're currently in player position X, player position Y, dot blocked, and in brackets we put north, direction north, equals false. Wow, I really don't like the look of that, but this is what we have to do. So, if we're not at the top of the map, and and north is not blocked, move them up, and then tell me they moved. So those are the 2 things we're going to do there. Check if we aren't at the top, and we can move upwards. Okay, move. So that's what we have to do. We have to do that for every direction, and then we're going to do it again for the editor. I'm going to make our life a little bit easier. We're actually going to pause for a moment. I'm not going to pause the video, but we are going to pause, and I'm going to implement a couple of properties which are going to make our life a little bit easier. So I want you to scroll down. We're going to go underneath end function there. And apologies for breaking the flow of the function just right now. And I'm going to create a public property called current room as a room. And this is going to return what room they're currently in. So this is what their current room is right here. So I don't want to have to write this 1,500 times. Rooms player position X, rooms player position Y. So copy this. I'm going to paste it here. So we're going to go return that. So that's the current room they're in. For setting the value, I'm going to go if value is not nothing, then that equals value. Alright, I know that probably looks weird, but I'm going to show you how much easier it makes our code. Please pause the video if you need time to catch up, because I'm about to minimize this guy and come back up, and we're going to finish off our move player. So let's do that now. This right here can now be changed into current room. See how much nicer that looks? So much better. Okay, so now we have to do every other case. This is for if they want to move north, then we're going to do south, east, and west. Okay, and it's literally going to be this. Again, I'm not going to pause the video. I'm going to hopefully do this with you. So if the direction is south, we want to make sure they don't go down. We're going to increase the y, sorry, I'll say that first. We're going to increase the value of 1 to move down on the y-axis. Now, we need to make sure we're not going to go through the bottom of our world. So, if our y is less than our height, and we actually have to put -1, strangely enough, and south is not blocked, we'll move down. Okay, so make sure we're not at the bottom. All right, I hope you're following me now because we're about to do east and west, and it's the same sort of thing. So east, so let's do west first because that's left. So if the x value is greater than 0 and west is not currently blocked, then -1 from x. So make sure we're not at the left side. And let's do east. If the x value is less than the width -1, and then put west in there, and then increase x by 1. Make sure we're not at the right side, and then I'm just going to get rid of these upwards. Alright. So, I hope you had time to follow exactly what the hell I was talking about, and then type up your own way, because how we need to do it, if in case we're in the editor, because this is if we're playing the game. Okay, because the editor is going to ignore this part. The editor is going to make sure they're inside the boundaries of the world. So, they are in the editor, move them. Select case, direction. So, case, direction, north. And this is actually much, much easier than last time. So, if the player position is greater than 0, then -1 off of it, and return true. And then south, and that's it. Let's do south is less than, it's the same thing that we had up above. It's going to be height -1. We're going to add 1 instead. Let's do east. X is greater than 0 and x -1. And let's do west. X is less than width -1. And add on to x. Alright, almost done. There's one last thing I want to do, and it's under the end if. We've returned lots of truths if they're allowed to move. If they're not allowed to move, we're going to end up down here. So let's return false. And that is our move player function done. Okay, it's pretty involved, but it saves us a lot of code in the editor and the game sections of the modules. So pause the video, type all that up, because I'm going to collapse this guy, and we're going to move on to the next one. So scroll up if you need to get any of that code for the player movement. All right, let's close this guy. All right, our next function. Let's go. I want to do displaying the room. So this is if they're playing the game, they've wandered across a room, and it's going to print out what's actually happening. So what we're going to do is it's going to have all those dotted lines. It's going to have you are currently standing in A and then the name of the room, the description of the room, and if you've got any items or any enemies, we need to build up that as well. So what we need to do is actually declare, so this string is to build the message for the screen. So let's dim, and I like to call them result, just for the hell of it. You can call it something else if you'd like. We're going to have lots of dashes at the top of the screen and a new line. All right, and then we're going to add the name and description. Now I'm pretty sure, let's have a quick look at room. I already had the name and the description. So what I'm going to do is I'm going to add on the current room dot print. So that probably sounds a bit more difficult than it really is. So I'm going to add on to result. So the way you add on to strings is concatenate equals, and that's going to take these dotted lines and the new line and add it onto result. And I'm going to go current room dot print. Okay, so that's going to get the name and the description of the room in there. However, just thinking about this, that's particularly ugly. I don't want to use dot print, do I? So we can't do that. Ignore me. Let's get rid of that. And let's go. We want the name. We want you are currently standing in A, and then we'll have the name of the room. So we're just going to have to do it a little bit of the long way. Current room name, a new line, and let's go. The description of the room actually comes straight after that. So current room dot description, and then a couple of new lines. Just so we've got some spaces, and that's it. So it's adding the name and description, and now here comes the really annoying part, to check if we have any items in the room. Okay, and if we have any items to the room, we've got to go through those items, we've got to add them to the list, and here's the annoying part, we've got to get the names from the global list in the room. Because every room doesn't have it, it's only got a reference to the item. So again, I'm going to break the flow of this function. I'm going to come down here and I'm going to write two little functions. Okay, one of them is going to be called getItem, the other one's going to be getEnemy. What we're going to do, this function is going to take an item reference and return the actual item. And the other one, as you can probably imagine, it's going to take the enemy reference and return an actual humanoid. So let's go public function getItem, if I can spell, item reference as an item reference, and we're going to return an item. So first of all, let's check, because the index is coming from the item reference, we need to make sure it's got a good index. So if the item reference's index is greater than or equal to 0 and item reference dot index is less than the count of items, so ensure we have our good index first. If all that's good, we're going to return the actual item that they want. And this is going to save us a lot of code, because if we wanted to get the name of every single item, we'd have to type in items, item reference dot index dot name. So it's going to be a lot easier now that we're doing this. Now, what happens if we didn't actually get the item we want? We're just going to return nothing in that case. And we'll get rid of that little squiggly. Copy this. Okay. Once you get there, paste, and we're going to change it to getEnemy. So enemy reference, which was a humanoid reference, and return a humanoid. Blup, blup, blup. What are you doing? And then we need enemies instead. Oh, okay. Almost there, people. Okay, let's go back up and let's finish off our display current room. So, how do we check if there's any enemy items, in the room? We check if current room items is greater than 0. If it is, here's the annoying part. We're going to say you see something, and then print each item to the screen. So found some items, print them. So result, equals you see something. And then a new line after it. Alright, and then we're going to loop through each item. For each item as item reference in current room.items. Let's add it to results. Hey, let's put some spaces first. And let's put the number of items, so the item.count times, and this is why we did the get item function. Get item, then put the item reference in there, dot name, and that's why we do it, because that looks so much neater than what we would have had to do otherwise. And then a new line afterwards. I'm sorry if that looks so ugly, but quickly going through it. So the current room, so the room only contains references to the items in the level. So we're going to go through each item as an item reference, and we're going to print how many there are on the screen, then the letter X, just so it's like, 2 times something, and then we call the get item reference with our item, if we call the get item function with our item reference, and it's going to return to us our actual item information. That's really long-winded. We're going to do the exact same thing for the enemies, so I want to copy this. I'm going to paste it just underneath. Alright, I'm going to change all this to the enemies. Get any enemies in the room. Change that to enemies. You see something? I'm going to change that to something is staring at you. Okay, each enemy as a humanoid reference in the current room enemies. And it is the enemy.count, get enemy, and pass it enemy. Alright. Last thing we have to do, return the message. Now I know how long-winded all that was, but this is actually probably one of the most important functions in the entire game, because this is what displays when the when the player is walking around the level. Whew. Okay. Guess what? We're almost there. The only 2 other functions I want to do are saving and loading. So finish up your display current room function. Pause the video if you have to. I'll scroll up if you need to pause there and type that up as well. But I'm going to minimize this guy and these guys. And we're going to go up to new level. There's a reason I didn't wrap this guy up. I don't know. And I'm going to put my functions right here. So this is for saving and loading the level, the whole level. So this can be used for when we're playing the game. It can also be used when we're editing the levels and when we're just saving changes for the levels, things like that. Because we've got a lot of information that we need to save, I'm going to be really cheap and nasty about this. And I'm going to use a technique called serialization, binary serialization to be very specific. And what that's going to do is VB is going to save all of my classes and all of my information straight into a binary file, and I'm going to be able to read it straight away, pull out all the information in one hit. Okay? The reason I'm doing this is because A, it's really quick to code, B, it's really easy, but I suppose the disadvantage of doing this is if we make any changes to a humanoid, a vector 2, a room, or anything else, or we add properties, we actually break the compatibility of our game to the previous levels that we've saved. So if we make a level with these settings and then go, oh, I want to add something to this or change a humanoid some way, you break your old saved files. I'm sorry about that. But anyway, this is just a quick way for us to do it. The way to get around that is then you have 2 classes. You have your old level class and you have your new level class. Okay, and then maybe you have a property for the version of the level that you've used. Anyway, that's another story for another day. So we can do the binary serialization, though, we actually need to include some stuff at the top. So let's scroll right up to the top, everyone, please, and make a space just here. And I'm going to go import system.io, which is input output, and then finally import system, runtime, serialization, formatters, binary. All right, and these 2 libraries, or I should say namespaces, are going to import all the variable types and all the information that we need to be able to save and load our levels. So let's make our first function, which is the save. So public function save. We're going to need, so how am I going to do this? We could do this a couple of ways. We can either save the level we're working on or make it a shared function. All right, we're going to make this a shared function, and I'm going to explain why in a bit. So the level as a level data type, and then the file name as a string. The return type is going to be a Boolean, just in case we get an error. So what this shared is it means any level is going to have this function, and it's going to be the same function. Alright, and the reason I do that is because then we can have multiple levels running at the same time, and we can just call on the save function and pass each level that we want to save. I know how weird that sounds, but it actually makes things a little bit more powerful than you probably expect. Alright, so first of all, to save using serializations, we have to create the variables that we're going to use. So create the variables for saving. So let's dim. First of all, we need a stream, which is what's going to be actually saving the content to our file. And it's going to equal file.create. And it wants a path, so we're just going to use file name. And then we need what's actually going to convert our class into a binary format to save it. And that's it. These are the two things that we need. Let's try and save. Now, because I just said the magic word, save the file, is try. Okay, because saving files, there can be so many issues, we're going to do a try and a save. So, to save the file, we do formatter, so this guy here, dot serialize. What do we want to serialize? We want to serialize to the stream, and the object is my level. Okay, and then you're going to close the file and cross your fingers. Now, if that worked, we should be able to return true at this point. If it failed for whatever reason, we're just going to return false, and it's completely up to the person who called this to handle how the error is going to be handled. Anyway, that's actually all we need to write for the save function, believe it or not. Let's pause the video if you need to do this, because I'm going to collapse him and write the load function, which is very, very similar in effect. So, public shared function, load, and we only need a file name this time, and we're going to return a level. Alright, so create the variables we need. So the variables for loading. First of all, we need the stream as a file stream equals file.openRead this time. Put the file name in there. Now we need the formatter as a new binary formatter, just like we did before. And the third thing we're going to need is a temporary variable for the level class. So this here is going to be what we return as our loaded level. Okay, try, because we don't want to stuff up. So load the level from file. Okay, then we go level equals formatter dot deserialize, and make sure you got the stream inside the brackets. Spell it correctly though, because I can't apparently. Then close your stream, otherwise you're going to have problems, and return true. Whoop, no, don't return true. Return level. If an error happens, we're going to return nothing. Alright. That's all the code for our level class. Now you can see why I broke that into its own video, because it's just an epic class. It does a lot of work. Okay? If you've got this code, please make sure you do, because I'm going to collapse this. Because there's one thing that I haven't done that we need to do to every single class inside our game. Because we're going to be saving all these classes using a serializer, we actually need to tag every single one of these classes as serializable. So just above, every time it says public class, we need to write in serializable in diamonds and with brackets after it. And that needs to appear above every other class that we've got here, because we're saving them all, except for direction, because it's not a class and it's not being saved. We need to have serializable. Otherwise, you're going to hit runtime errors when you try and save and load your files. Okay? So let's do that to every single class. So double click, paste it, double click, paste it, and just keep on going in that fashion, hey? Almost there. And that's it. Okay. I know how long-winded that was. I know that some of you might have not caught up and might take you a lot longer than I did. Again, source code in the description of the video. It'll be in the next one as well. I hope you got this one going because we're ready to tackle the editor, which, believe you me, is still pretty big, but it's actually not too bad at all. All right, good luck, everybody. Thank you for watching this video. I'll see you in the next part for the editor. See you then.